The name erratic refers to a boulder which differs from its surroundings, transported from a distance by glacial drift. Just like the erratic, our homes are composed of displaced materials settled into unfamiliar terrain. Home is where your data is, and if we impose form on matter, hiding it inside of clean walls, we render that data illegible. Home erratic reimagines the construction of a home as an interval in time flowing with the movement of matter rather than against it. Alongside the erratic, the melting glaciers drag small rocks and other sediments. This process means the Arctic is one of the only places in the world with a growing supply of sand, and as it spills into the fjord, dredging ships parse the sediment to retrieve the valuable aggregate. Boats deliver the material to the wharf at noon, where it's transferred to trucks and taken to be stored in sand pits. The city's population is projected to double in 10 years, and accordingly they plan to use their new supply of sand to construct concrete apartment blocks. Instead, we will be diverting this sand just 3 kilometers away to land on a rocky site on the northern coast of the peninsula. The sand arrives, delivered by conveyor onto the site. The sand innately behaves following certain principles. A construction that leverages these principles will gain efficiency while preserving traces of the material origin. Fundamentally, we can treat the sand as self-organizing formwork. Pouring concrete onto the sand form, we can 3D scan the resulting shell to analyze details of the interaction. The angle of repose ensures that aggregate materials will always settle at the same angle, giving us the universal form of the sand pile that we typically see on construction sites. By coordinating multiple pores, compound motions, and sequence, we can depart from the universal geometry and discover new forms for earthwork cast shells. This iterative process is cataloged in an index of cast sand forms. Deviating from the basic sand pile, we explore techniques of sequencing to create layers of enclosure. Compacting the sand with water creates a more stable surface to direct flow, allowing the shells to capture intricate intersection geometries between piles. By beginning the process with a reservoir to collect the overflow, the magmatic forms can be coordinated to terminate at specific boundaries. Channels carved along the form house lateral reinforcing levers in a nervous system that spans the shell. Openings are incorporated by sequencing pores to divert flow. The inclusion of hardware suspended in the layers allows for reinforcement of sequential casts. Once reinforcement, joinery, foundations, and openings are all accounted for, we can speculate on the spatial opportunities within. Studying the models in section, it is evident that the roughness of the formwork leads to irregularities. These shells are not perfect geometric forms, rather they are records of the buildup of sequential pores. Each pore amplifies the imperfections of the one below, sometimes adding new discrepancies in the process. Up close, the textured surface reflects each individual grain of sand. From afar, the macro form of the enclosure registers the constructive process and the materials that were once piled there. Outside, a perimeter ring doubles as overflow reservoir and foundation, creating a lip between the shell and the rocky terrain. Above the cliff on the southern elevation, the apex of each shell reaches up to act as a light bulb, permitting daylight to the interior space. The elevation reads as 4 discrete shells, but looking inside reveals the structural network uniting them into a continuous system braced against the rock. Inside, the flow of the concrete creates a meandering floor slab, sloping according to the composition of the terrain below. The oblique entrance slips past the rocks, providing a covered path into the building. The door swings upward, propped by gas struts to permit the occupant into the interior of the shell. The typical section is characterized by the relation of the foundation and the enclosure. Anchors are drilled and grouted into the bedrock before being engulfed by accumulating layers of different concrete mixtures, insulation, and embedded systems. The foundations rise up to meet the shell, which brings diffuse light in from above the rocks through a translucent epoxy resin screen. Inside, the edges of the slab rise up to create low partitions, opportunities for locating utilities such as the fireplace, laundry, and bath. A single stair lets the occupants walk directly up to the top of the rock face, where natural light is brightest for reading and work. Given enough time, even solid materials will flow. Home Erratic demonstrates that construction does not need to conform to traditions that disrupt the geological flow of matter. We are overthinking the process by insisting that concrete or sand need to end up in orthogonal systems of vertical walls. We gain construction efficiency from the innate material properties, and a home which better serves to archive the instant in time when the sand was here before it continued on its journey someplace else.